The last video when I introduced to you the input arguments for HGLM, so how you call the HGLM function. And in this one, I'm going to explain to you about the outputs of HGLM. So how do you interpret your results after calling the HGLM function. So I have my R open in my terminal window. I have the HGLM package already loaded. So let's first call the HGLM help. If we scroll down to, here's a list of values. Right, so you see value, and then it tells you all the output list. What are these stuff that you get from the HGLM object after you feed the model. But I'm going to introduce to you about all this stuff by taking the first example from the examples here, and this semiconductor example where you have a lot of stuff. So this example, just quickly go through it. So we load the data semiconductor. What we feed is HGLM with some fixed effects, 4 of them, and random effects called Deviance as random effects. And this is a gamma model with a link function log. And we also have a dispersion model with 2 variables explaining the variance of the response as fitted by HGLM, and we have some summary, and we have a plot. So you fit. So first of all, we fit the model using HGLM, and then we call summary on this object. We can get some summary of the results, and then we can plot this object also. So just simply copy and paste all this stuff and run it on the computer. Okay, now it's not plotted because I haven't entered here, which is good. So before we plot the object, let's go through the summary output of HGLM. So the summary is actually a long list, depending on how many stuff you have in the model, of course. So first is specify call, and this is basically summarizing how did you call the HGLM function for you to check what you have done. And then you have sections, right? See, so when you don't have a dispersion model, you simply always see a mean model here. So when you only have mean model property, this doesn't make too much sense to you. But if you have a dispersion model, you see that you have 2 pieces of summary. So the mean model, it summarizes. So what is a mean model? That's the linear predictor for the response, for the expectation or the magnitude of your response. So it should usually include fixed effects, random effects, estimates. So the mean model, we have a summary table for the fixed effects estimates. We have 4 variables, x1, x3, x5, x6 in this case, and the intercept. We have standard error estimated, t-value corresponding to that, and p-value calculated as well. Let's speed out the degrees of freedom, 52 in this case, and a summary table for the random effects with some estimates and the standard error. So this standard is actually the prediction error if you check some literature. It's slightly different from the standard error here in the fixed effects. In the latest version, we have a lot of random effects, and usually you do have a lot because that's sometimes the basic reason for you to use random effects. So in the latest version of HGLM package, after 3 random effects list, we have a ... So just ignores the remaining. If you want all of them, you can print summary the HGLM object, and you specify print ran if equal to true. You get all the printouts of the random effects. And then this is followed by the dispersion model summary, And it says some notes, H likelihood estimates through EQL can be biased, but usually you should probably ignore this because this is something theoretical, not usually matter that much. So we have model dispersion, well, model estimate for the dispersion term, and it says link equal to log and some effects. What does that mean? So what is a dispersion model? So dispersion model is basically a model for the variance, right? So the variance is modeled as a gamma linear model internally, because variance is bounded at 0, is always positive, so it's not normal, and theoretically it's a gamma model with fitting. So when we fit the gamma model, we take the log link. This can be user specified, but usually it's log. And these are the effects estimate for the dispersion part. So you can reconstruct the linear predictor from these estimates, and then you take E, which is the power of this, you get a variance estimate. And that is what we get here, the dispersion parameter for the random effects. And then we have dispersion model for the random effects. Well, sorry, the linear predictors here. So this is the model for the residual variance, and then we have a model for the random effects. The estimate is in the linear predictor for the other gamma model. If you take the inverse power of that, you get 0.0486. This is a dispersion parameter or variance component for the random effects. All of them specified dispersion equal to 1 is used in the gamma model on deviances to calculate the standard errors. So the dispersion parameter for the gamma distribution is fixed to be 1. This is just a note. And also in the HGLM function, you usually see this. So that's it. So if you go through the summary, you get all the information for fixed effect estimates, random effect estimates for the mean, estimates for the dispersion model, and also variance component summary. So it's a full summary of the result. At the end, it says EQL estimation convergent in 4 iterations. Sometimes you should check this. So if it's 2 iterations, probably need more, because it's very unnatural to have a algorithm converge in 2 iterations. 4 is okay. So actually, this HGLM algorithm converges pretty fast, so which is nice. Okay, after going through the summary, let's plot the object, and let's specify some point size adjustments, but that doesn't really matter. You can just plot the object directly, and it spits out quite a few figures actually. In this case, because we have a dispersion model. If you don't have a dispersion model, you have less, I think 1 figure less than this. So okay, now I get lost which one is the first one. So cos 3, 4. This is the first one. We take here. So the first figure you get by plotting the HGLM object is a model checking figure for the mean model. So the mean part of the model. It has 4 parts. The first one is a plot of studentized residuals considered as a function of fitted values, so plot against each other. This is basically for checking whether the standardized or studentized, that's a standardization using hat values and variance as well, to check whether it's sort of independent or random residual that we get. And then we have the second figure, which is just an absolute value of the first one for you to check. C panel here is a QQ plot for the residuals. So the studentized residual should be theoretically normal. So if it doesn't follow normal, it's something weird. And here it looks pretty nicely. The D panel is a histogram of the studentized residuals to see whether it's normal or not. Slightly deviates from normal, but it's good good enough in this case, I think. Let's close it. The second window of figure you get from plotting is a model checking figure for the dispersion model. If you don't have a dispersion part of the model, this will not be generated. And here we have standardized deviance residuals. This is something difficult to understand. You should probably check our paper or the vignette to understand that. So the deviance residual is especially useful when you have a non-normal response. In this case, it's gamma because it's a dispersion model for the variance component. It's checking whether it's random or not. And the B panel is still absolute value for the first one. The C panel is a QQ plot for the residuals. D panel is histogram. That's very similar to the mean part of the model. Close this. And this figure shows you the hat values and deviances of HGLM. So what is the hat value? Oh, I would not explain this here, but you should check the our documentation or the papers. So it basically tells you how influential the observations are on the estimates. The next figure is for checking the deviances used for estimating the variance component. So the variance component in the HGLM is fitted by a gamma GLM. And that is actually why it's called a hierarchical generalized linear model, because each part of the model can be interpreted as a generalized linear model, GLM. So for the variance, we have a gamma GLM. For the gamma GLM, we have deviance as response. And the deviance should follow gamma, of course, otherwise it doesn't make sense, it's a gamma model. So here we have a QQ plot for the gamma distribution to check the deviance, whether they are following a gamma distribution. And here is a histogram. Since we have two variance components, usually we have two residual and random effects. So we have two rows of figures checking the deviances, whether they are gamma distributed or not. So that's it. That's a lot of model checking figures by plotting the HGLM fitted object. Another thing is that if you simply call the fitted object, you get a short list of summary of your result. So this is a print out, a print function on the HGLM object. Here you also have a for more random effects, you can print result, print ran if equal to true argument specified. This is a short summary. If you take a summary, you have a longer summary. That's the difference. What else? So then we go to the detailed list of outputs that you can actually use later on. So we have an object M11 already fitted, and inside that we have a lot of variables that's calculated. Alright, so if you call names M11, we have this stuff. That's basically the same thing as the stuff in the list of values in the documentation that you can check. So I'm going to go through this one by one. So M11 call, so we can call this M11 $call. That's simply the function call that you just made. And then you have M11 fixed if, that's a fixed effect estimate. Ran if is a random effect estimate. Ran C, you should check the last video for more random effect terms. This is not useful for this particular example. This is basically the number of columns internally for the random effects, different random effects. And we have some phi. Well, I have to check what is phi. It's just a vector of dispersion parameters. So this is basically not useful. We should probably remove this. in the future. So what is important is this var fix and var ranif. So these two give you the variance component estimate for the fixed effect for the residual actually, and the variance component estimate for the random effect. So these two are pretty important to know. Number of iterations is iter, they are converge or not, specified by this converge. SEFE is the standard error for the fixed effects, SERE is the standard errors for the random effects. And DFREFE is the degrees of freedom calculated using some specific formula in the package. And then you have sum VC1, sum VC2 is a summary of the two variance component estimates that you can call. Method is just taking the method that you use, and currently it's just EQL if you have watched the last video. Deviance, right, calculated from the residuals. It's basically the squared residuals divided by 1 minus hat value, if I remember correctly. HV is hat values, receipt is the raw residuals, FV is the fitted values by the model. So removing the residual part, what is your predictor for the response using the fitted effects and the linear predictor. Disp FV, so this is a fitted value for the dispersion part of the model and the residual for the dispersion part of the model. This receipt link.disp is basically taking the link from the dispersion model that you specified. Log usually, so it's not very useful. variance covariance matrix for the observations. In this case, we didn't specify it to be true, so it's not there, I think. So if we call yes, no. So it didn't specify. We don't want this to be output. And likelihood is something useful that you have likelihood calculated and also some information criteria. In this case, I don't think we had nothing fitted by this, but this can be done by. So now we need to refit the model. So okay, so wait, I need to go back to the documentation, grab this. Oops, grab this example. So to show you the likelihood argument. So if we call calc like equal to true, and then we will have some output in the likelihood. Yes. So in the likelihood we have a list if you specify it to be true. A list of 4 different stuff. The first one, H leak, is the H likelihood, the full likelihood for the entire model calculated. PVH is the profile likelihood, the profiling out the random effects. PBVH is the profile likelihood, profiling out both the fixed and random effects. And this is the conditional ICAG information criterion CAIC, given also here. And for profile likelihood, you should, this likelihood functions, you check the papers and our documentation to understand what is that. And if you are familiar with HGLM, you will know what they really are. And that's it. That's my description for the output, or how to interpret the results using the HGLM function. And thanks for watching.